Right, people, here's the next lesson. I'm again referring to the handout on principle of moments. If I quickly flash back to it, okay, that was spoke about in the beginning. I just worked to that one before this one. I'm looking at example 3.2 right now. Okay, it says calculate the moment of the force acting about the fulcrum, which is the center of the nut. There we go. Let's have a go with that. Right, what's the definition of a moment? Force multiplied by perpendicular distance. Now, in the previous one, which was that one there, okay, we had force multiplied by distance. Okay, now how different is this one? Is it the same? Notice there, the force is 32 newtons, the distance is 0.25 meters, but it's not acting at right angles to the point of rotation. Okay, so we can't say that the moment is 32 multiplied by 0.25. That will be wrong. Okay, right, so what we're gonna do, we first gonna, just from here, we're gonna draw a line. Let me just do something quickly like so. I'm gonna draw a line. I'm gonna extend the line of action of that force there, and then I'm gonna draw a line through the point of rotation, which is over there, at right angles to that force there, and there's my right angle there, and I'm just extending that force, even though it's acting up there. Okay, it's still acting over there, so that's my 32 newtons. Okay, there's my point of rotation, A, B, or whatever. I'm just calling it A. Right, let's take moments of it A. So the sum of the moments with A is equal to, okay, there's the point of rotation. This force, even though it's acting this way, will have an effect about that point there, so it's going to be positive. So it's plus 32 newtons multiplied by, and it's not multiplied by 0.250, it's by that little distance over there. We'll call it little d. Okay, do we know what it is? No, we don't know what it is, but we know that 60, and that angle there is also 60 degrees. So we know the angle there, we know the length of the hypotenuse, which is 0.25 meters. Therefore, using famous old trigonometry, we can work at what little d is. And once we know what little d is in terms of that angle, the hypotenuse there, we can put it into our formula there, and we can find the moments about A. Right, let's do the trigonometry. So let's see, what is it going to be? It is going to be the sine of 60 degrees is equal to small d over the hypotenuse, which is 0.25. Okay, so therefore, d is equal to 0.25 times the sine of 60 degrees. Okay, I'm not going to work it out. I'm going to work it out there. So 32 times little d, but little d is 0.25 times 60. So it's 0.25 times sine 60 is equal to, pick up my calculator, and you work out the answer, and I get 6.93. So 6.93 Newton meters. Okay, Newton meters, not per meter, Newton meters, force times distance. And because the answer is positive, it means that our lever is going to want to go that way. Okay, right, people, that's the end of that lesson, and I'll see you in the next lesson.